The effects of AKDC in polynomial functions of the form f of x is equal to a k x minus d to the power of n plus c. So first we're going to look at when c is greater than 0. We can translate c units up translate or shift c units up. When c is less than 0, we can say translate or shift c units down. For the value of d, we can say translate or shift d units right. When d is less than 0, we can write translate or shift d units left. So d is less than 0, that means the values are negative. We can take the absolute of it. So we can just write here, let's say if it's d is negative 3, we can say translate 3 units left instead of saying minus 3 units left. The value of a, when a is greater than 1 or a is less than negative 1, we can say vertical stretch by a factor of absolute value of a, means it should be positive. When a is between negative 1 and 1, we can write the transformation as vertical compression by a factor of absolute value of a. When it's a is less than 0, we can write vertical reflection or reflection in the x-axis. Reflection in the x-axis. For the values of k, when k is greater than 1 or k is less than negative 1, we can write horizontal compression by a factor of 1 over absolute value of k. When k is between negative 1 and 1, we can say horizontal stretch by a factor of 1 over absolute value of k. And when k is less than 0, we can write reflection in the y-axis. We can see from the table a and c causes vertical transformation, therefore it affects the y coordinates of the function. K and D cause horizontal transformation and therefore affect the x coordinates of the function. Whenever we are applying the transformation to the parent function, or the base function, make sure to apply the transformation represented by A and K before the transformations represented by D and C.